All right, we just covered the relationship between regression and correlation, and now we need to focus on the connection between regression and analysis of variance. The coefficient of determination and non-determination that we just discussed are proportions of explained and unexplained variation, respectively. And so this puts us kind of squarely in the language of analysis of variance when we're talking about um, sums of squares. And the sums of squares requirement applies to analysis of variance as well. We have the sums of squares for the regression, which is associated with the degrees of freedom of 1. And we have a sum of squares for the error, which is associated with the degrees of freedom n minus 2. And so if I have the sum of squares for regression, that's essentially r squared times the sums of squares for total. And so if I want to arrive at sums of squares for error, I can take the coefficient of non-determination and multiply it by the sums of squares for the total. So if you remember back with the analysis of variance source table, there was the sums of squares total, and that applies to the connection between analysis of variance and regression. So I can calculate mean square and mean square for regression and mean square for our error term by dividing the sums of squares by the respective degrees of freedom, just like I did in Chapter 8 for analysis of variance. After I do that, then I can calculate the F ratio for testing the significance of the regression and coming up with the table in Appendix C. Now, instead of, remember with Chapter 8, we solved for the F ratio by taking mean square between divided by mean square within. This time the F ratio is the mean square for the regression divided by the mean square for error. So essentially the purpose of these last two lectures is to help you realize the relationships between all of these procedures. They all refer to the general technique of general linear model, and so they're all kind of variations on one another. Every analysis you can do with an analysis of variance, you can also do with the regression and vice versa.